Since linked lists consist of structures that are dynamically allocated, all of the elements are accessed using pointers. It is therefore useful to define a couple of types. We can define a type for a struct for each element. So this would have all of the individual data members, and then it would have a next pointer to the next element in the linked list. So it's useful to define a type for that, and also, since all of these pointers are pointing to these structures, it's useful to have a type for that as well, a pointer to one of these elements. So in C, we can have type defs for both of these things. So first of all, I'm going to define a type using type def, and the type is going to be called element, and it is a structure. So using type def, I'm renaming all of this structure declaration as element. So the structure is going to have two members in it, data, which is an integer, and next, which is a pointer to one of these structures. Now I basically want to say that next points to something of the type element, but up here on this line I don't have the word element yet. It's on the next line. And so I use this thing that is sometimes called an optional tag. It's not so optional now. I need a way of referring to this structure while we're in the middle of declaring the structure. So struct linked list is a way of referring to this structure. So again, we have two members, data, which is an integer, and next, which is a pointer to one of these structures of the type that I'm now going to call element. So since everything points to structures of the type element, it's also useful to have a type def to redefine a pointer to an element as a name. In this case, I called it element PTR, short for element pointer. So it's very useful to have both of those type defs. So then to declare variables, once we have the types, I've got my type element pointer. I can use that to declare a first pointer to point to the first element in the linked list, a last pointer to point to the last element in the linked list, and frequently we're going to have some other pointer that points somewhere in the linked list to what we call a current element. Now to create the linked list, the first element is always a special case because we're going to be using the first pointer. So basically there are four statements. First of all, we're going to dynamically allocate a new location large enough for one of these structures of the type element, and we're going to return the address as an element pointer. So this dynamically allocates the location, and then we're assigning that to first. So our variable first is going to point to this location. Okay, so we dynamically allocate and first points to it. Then, since this is the first element, it's also the last element, so we're going to set last equal to first. So we have our variable last, and now it's going to equal first, meaning that they both point to the same thing. Then I want to put values in the members. So last arrow data gets value 5, last arrow gets me to the structure, data gets me to the integer data member. We're going to put a 5 in there, and then we're going to make the next pointer null. So that's a simple linked list, a very simple linked list. It just has one element in it. But first points to the beginning, last points to the end, the last next pointer has the value null. Now to add an element to the end of the linked list, we assign the address of a dynamically allocated element to last arrow next, so that we're actually connecting this new element to the linked list. So again, we're going to have four statements basically that accomplish this. We're going to dynamically allocate enough space in memory for one of these structures of the type element and return it as an element pointer. So we're dynamically allocating enough space in memory for one of these structures. And we're storing the address in last arrow next. So last arrow next is this pointer. So instead of having the value null, now it's going to point to this new element. So now last is not pointing to the last element anymore, and we need to fix that. So last gets the value of last arrow next. Last arrow next is pointing to this structure, so setting last equal to that means last is also going to point to this structure. Okay, then we need to initialize the members. Last arrow data gets the value of 12, so the data member is going to be 12, and this is the last element in the linked list, so the next pointer is going to become null. So basically, anytime we want to add another element to the end of the linked list, these four statements will accomplish it. So obviously the 12 is not general, and that's just an arbitrary number. But in order to add another element to the end of the linked list, you need to dynamically allocate a new element, set the address equal to last arrow next so that it's hooked up to the linked list, move last to that new element, put something in the data member somehow, maybe you're reading it from a file, for example, and then make the last next pointer null. So you can do that as many times as you want in any kind of a loop. Usually it'll be some kind of a conditional loop. For example, if you're looping until you get to the end of the file, you're creating new elements for all of the data values from the file and reading them in.